Hello there, Mr. Sutton here with the AB Calculus 4-6 homework solutions on graphical analysis. For this problem, we have some f function that we're trying to figure out what it looks like, and we're told that it is continuous on the interval -2 to 3, which not all of these are, but they're at least all on closed intervals. We're also told f prime of 0 does not exist, f prime of 2 is 0, and f double prime of x is less than 0 everywhere except, of course, x equals 0. Because it doesn't exist there, or f prime doesn't exist there. So we're going to go through each of these and eliminate what we can. So taking a look at choice A, it looks like, let's see here, f prime of 0 does not exist. We've got a cusp there. It's continuous. And f prime of 2 equals 0. We have a smooth turnaround at 2. In fact, we have a smooth turnaround at 2 for, it looks like, all of these graphs here. So this condition right here isn't going to help us a whole lot. But let's look at this last one. So they're saying that we are concave down across the entire interval except for x equals 0. Well, from -2 to 0, a is actually concave up. F double prime is positive there. So we can eliminate that one. Now for choice B, we have the same kind of issue, except that this time around we're concave up on the interval from 0 to 3. So that also violates this last condition. And then for choice C, well, we've got concave down across the whole interval, actually, including at x equals 0, and that's also a problem. They said f prime of 0 does not exist, but in choice C, it clearly does. It's not a cusp or anything special. It's just part of the function. So because f prime of 0 exists in choice C, we can eliminate that one. Choice D is a little bit trickier if you're not reading carefully. F prime of 0 does not exist. We've got concave down everywhere else. We have our smooth turnaround. What this is violating, in the very beginning, they said our function is continuous. This is not. This is a jump here. So that means that because we're not continuous, D can also be eliminated. That leaves us by process of elimination with choice E. Now let's just go through all the conditions with E just to be sure. E is definitely continuous. And f prime of 0, we've got a cusp at 0. So f prime of 0 does not exist for that reason. We also have a smooth turnaround, or you could say a horizontal tangent line, at x equals 2. And then finally, we are concave down everywhere except for x equals 0. So that means that we can also say this last condition is met. So all that gives us choice E. For this problem, we're given that f prime of x is absolute value of x minus 2. We want to know what the graph of f looks like. So you got to be careful here. This choice A is actually what absolute value of x minus 2 looks like, but they didn't want f prime. They wanted the graph of f. So this graph right here is conveniently the graph of f prime. We're trying to find an f that matches this. So what can we tell just by looking at this graph, which happens to be exactly the function we're talking about? Well, this graph is positive everywhere, or 0. So we can say in general f prime of x is greater than or equal to 0. This tells us that the original function is always going to be increasing, or at least non-decreasing. So that's going to rule out answer choices B, which is decreasing right here, and answer choice C, which is decreasing here, and also between 2 and 4. That leaves us with D versus E. And the main difference in here, I mean, they're both increasing, and they actually have the exact same slopes everywhere, except the only difference is, obviously, we have this jump at 2 in one of them and not in the other one. Well, if we had the jump like this in the original, then the derivative would be undefined at this spot, not 0. So because our original function, or our derivative, our f prime here, is differentiable, since there's no places where it has gaps or anything like that, that tells us that choice D cannot be it. It's got to be the continuous one, choice E, because if you're differentiable, you're also continuous. For this problem, we're given a differentiable graph of f, and we want to know which order to put the first derivative of a few values of this graph in. So I think it would be helpful just to figure out what these values are, and then we can order them. Let's start with f prime of -2. So that's right here. The slope right here is what we're looking at. And it's hard to tell exactly what the slope is because there's no scale on the y-axis. However, we can at least say that this is a positive f prime. And moving over to f prime of 0, this is actually 0. That's the only one we actually can tell because it's completely horizontal there. And finally, f prime of 3, that's going to be a negative slope. Beyond that, who knows? So if we're trying to put these in order, clearly we have to start with the one that's negative. It beats out the 0 and the positive one for first spot. So f prime of 3 is going first. That narrows it down to choices C and D already. And then after a negative number, we've got something that's 0. It's going to come before something that's positive. So f prime of 0 is next. And we can say then that that is less than f prime of negative 2. So that's going to be answer choice D. For this problem, we're given the graph of f prime. We want to know where the original graph f has a local max. So we're looking for places where f prime is changing from positive to negative. I notice f prime changes positive to negative here at x equals 1. So therefore, f has a local max at x equals 1, which is going to give us answer choice C. For this problem, we've got the graph of f prime, and we want to know which statement is true about f. All right, so we're going to go through and eliminate what we can for these. First statement, f is decreasing for negative 1 to 1. Well, if we look at the graph between negative 1 and 1, the graph of f prime is decreasing, but that doesn't necessarily mean f is decreasing. So f prime is telling us, the sign of f prime is telling us whether or not f is decreasing. And for part of the interval that they gave us, namely between negative 1 and 0, really from negative 2 to 0, that whole interval, f prime is positive, which means that the f function is actually going to be increasing on that whole interval. So this is a no for answer choice A because we're not decreasing on this whole interval for the original function. Now taking a look at B, f is increasing from negative 2 to 0. Well, we basically just said that, so that's a yes, C above here. So that would be a good one to pick, but if you want to look at the other ones, f is increasing 1 to 2. Well, f prime is negative from 0 to 2. So that means we're going to be actually decreasing on the interval that they're talking about. So that's a no. F has a local minimum at x equals 0. Okay, well, we are changing signs at least for f prime, so that gives us an extremum. However, we're changing from positive to negative for f prime. That would actually give us the location of a local max if you're increasing until then and then you're decreasing. So because that's a max, it can't be a min, so that's a no. And then this last one, f is not differentiable at x equals negative 1 and 1. Well, they're still kind of counting on you mixing up the graph of f and f prime. If we were talking about the graph of f double prime, it would not be differentiable at these corners. But for the graph of f prime, I mean, they're saying basically that f prime doesn't exist at x equals negative 1 and 1. And it clearly does exist. F of negative 1 exists, f of 1 exists, they're there, they're solid. Their derivative doesn't exist there. The derivative of f prime doesn't exist, but f prime itself does exist there. Therefore, f is differentiable, and this is also a no. So at the end of the day then, choice B. On this problem, we are given the first derivative of a function f. It's this f prime, and it's the product of a quadratic and some weird sine function. And this is on the interval from negative to positive 1.5. We want to know where the graph of f is concave up on this same interval. So in order to figure that out, I'm going to figure out what f double prime is doing. I'm going to graph that out using my graphing calculator, my Desmos, and we're just going to see where f double prime is positive. So let me first get f double prime. For that, I am going to need my product rule. This is a product of two functions that I can't really simplify otherwise. So I'll use my box and ribbon for this. So I'm going to have my u value, x squared plus 1, and my v value, that's sine of 3x minus 1. And now u prime, derivative of this, is going to be 2x. And then the derivative of sine of all that is going to be cosine of 3x minus 1, times, using our chain rule, the derivative of 3x minus 1, so times 3. Now putting this all together, we've got u prime v, so 2x times sine of 3x minus 1, plus uv prime, x squared plus 1 in a parentheses, times cosine of all that stuff. And at this point, I'm just going to see where this equals 0 on my Desmos. So here we go. So just fired up Desmos here. Let me put this function in. I'm just going to call it g. And we've got 2x sine of 3x minus 1 plus, and now parentheses, x squared plus 1 times cosine of 3x minus 1. Careful with those parentheses. And then times that 3 at the end. And if we look at this, this is definitely a big mess. But fortunately, we only care about the interval from negative to positive 1.5. So let me go and put that in there. And let me make it like negative 1.7 and positive 1.7, just so I can get a full look at what this thing is doing. All right, so here is my function on that interval. And just kind of clicking my function and seeing where we're crossing the x-axis, we're crossing at negative 1.341. And also, we've got negative 0.240. And finally, this last one, positive 0.964. And just double checking, all of these intercepts are between negative 1.5 and positive 1.5. All right, so there's the picture that I just had, and those are my x-intercepts. Again, negative 1.3, negative 1.341, 0.240, 0.964. Now, doing a little sign analysis, I see that f double prime is positive on the interval from negative 1.5 to negative 1.341. And also above the x-axis, also positive on this interval from negative 0.240 to positive 0.964. Since f double prime is positive on that interval, that means that f itself is going to be concave up on those same two intervals. So taking a look at my answer choices, we have negative 1.5, negative 1.341, and then we've got the other interval, so choice A. On this problem, we are given the graph of f up here. We want to know which of these could be the graph of the derivative of f, so in other words, f prime. So one thing I'm going to be looking for is maxes and mins on f turning into x-intercepts on f prime. I notice that I've got one maximum here for f. That means that at exactly one spot, f prime is going to be changing from positive to negative. So we're going to have exactly 1, 0, and it's going to be a positive to negative change. Looking at my answer choices, it looks like choice A has just that, positive to negative. And choice B has two x-intercepts, so we can eliminate that one. Choice C is going negative to positive. That's the wrong direction. Also can be eliminated. Choice D's got two intersections, so it's really eliminating B, C, and D, and we're down to A versus E. Now, one other key feature of this graph is that the concavity is changing. We're concave up, then down, then up. Since we're changing concavity, that means that the direction of f prime is going to be reversing at some point to reflect the change in concavity. So between A and E, the only one where f prime, this is the graph of f prime, the only one where it's reversing directions at all is choice A. Choice E, we're just going the same direction the whole time for that first derivative. So we can eliminate E and choose A. For this problem, we have some g function that's defined and differentiable from negative 7 to 5, and they're telling us g of 0 equals 5, which may or may not be helpful on this particular problem. Graph of g prime is given up here. Okay, so we want the x-coordinate of each point of inflection for g. Well, those are going to happen wherever g prime is reversing directions. We notice that g prime changes from increasing to decreasing or decreasing to increasing at the x values 0 and 2 and also positive 3, and just those. So that means that g itself has points of inflection at x equals 0, 2, and 3 for this reason of the direction change. For this problem, we have f defined on the closed interval negative 3 to 4, and f of 0 is 3. Here's the graph of f prime. We want to know on what intervals, for our first task here, is f itself increasing. Well, f is going to be increasing wherever f prime is positive. F prime is positive on the interval from negative 3 to negative 2, and also, actually, that's it. That's the only one. So that means that on the interval from negative 3 to 2, f is increasing, and that's not the case anywhere else. For this part, they want us to find the x-coordinate of each point of inflection on the graph and justify the answer. So f is going to have a point of inflection wherever f prime has a min or a max. So whether f prime is going from positive or increasing to decreasing or decreasing to increasing is what it is. Looking at the graph here, we see that f prime goes from decreasing to increasing at x equals 0 and increasing to decreasing at x equals 2. So it reverses directions, one direction or the other, at 0 and 2. Therefore, f has a point of inflection at x equals 0 and 2. For this last part here, they want us to find an equation for the line tangent to the graph of f at 0, 3. So since I'm just finding a normal tangent line and not doing anything with it, I'm just going to use point slope, y minus y1 equals m times x minus x1. So I have y minus the y value they gave me, 3, equals the slope. Now I don't know what the slope is, but it's going to be f prime of the x value 0, so whatever that comes out to is going to be our slope. And then we're going to have x minus 0 because they gave us that point here. So let's see here, f prime of 0, we just have to look up the output value, the y value in this graph here of when we plug in 0 for x. So we see that f prime has a value of negative 2 in that situation. So we've got y minus 3 equals minus 2 parentheses x minus 0. And of course you could distribute the x and simplify it if you wanted.